From an airplane flying over the ocean, the angle of depression to a submarine lying under the surface is 24 degrees 10 minutes. At the same moment, the angle of depression from the airplane to a battleship is 17 degrees 30 minutes. The distance from the airplane to the battleship is 5,120 feet. Find the distance between the battleship and the submarine. Assume the airplane, submarine, and battleship are all in like a common plane. Okay, so you can think about the airplane has some sort of angle measurement device in it. You know, it's hard to get distances between far-off features, but angles, it's easier to determine between far-off features. So it determines, the airplane in the cockpit determines that the angle of depression of the submarine, so the angle of depression is the angle under the horizontal to the submarine, is 24 degrees 10 minutes, and the angle of depression to the line of the battleship is 17 degrees 30 minutes. And then the distance from the airplane to the battleship is 5,120 feet. And it wants us to calculate what this distance must be, the distance between the submarine and the battleship. Okay, so let's see. Let's draw some extra lines in here so we can just get a sense for what we have. Okay, this would be right angles. Okay, this is the height of the plane above the surface of the water. Okay, let's see. We've got this. There's a right triangle up here, and we've got the hypotenuse and an angle. So we can fully solve this right triangle if we need. So we can get this height, we can get this length, this angle. But if we can, we'd like to get as much information we can about this middle triangle because we're looking for x. We could use the law of sines. Once we get enough information, we could use the law of sines or cosines on this middle triangle. So we've got a side length on the middle triangle, and we can get an angle. So let's go ahead and get that. Let's get this angle here, this angle of the triangle here. So, okay, 24 degrees 10 minutes minus 17 degrees 30 minutes. So 24 degrees 10 minutes minus 17 degrees 30 minutes. So let's see. 24 minus 17 is 7, but then you would, so you take away 17 from 24, you get 7. Then you take away 30 minutes from 10 minutes, and that takes you all the way down to 40 minutes. So 6 degrees, 40 minutes. Okay, so this is 6 degrees, 40 minutes. Okay, so now we have an angle and a side length, but we can get another angle for sure. In fact, we can see that if these two lines are parallel, which we can say they are, then we have alternate interior angles. This is going to be 17 degrees, 30 minutes. So now we have two angles and a side length. Okay, so we could use the law of sines. Angle, side, angle. So, okay, but to use the law of sines, we're going to need this angle. So let's get that angle. So we need to subtract from 180 degrees, 0 minutes. We need to subtract 17 degrees, 30 minutes, and 6 degrees, 40 minutes. So, okay, 180 minus 17 is going to be what, 163? And then minus 6 from that is going to be 157. Okay, but then subtracting from that, let's see, so you take away 30 from 180, then you're at 179, 30 minutes. You take another 40 from 180, then you're at 178, 50 minutes. So what's 178 minus 17 minus 6? So that's 155 degrees. So if we subtract all this, 50 minutes. So 155 degrees, 50 minutes. Okay. So we've got the law of sines on that middle triangle. We've got x over the sine of 6 degrees, 40 minutes. That's going to be 40 minutes. 40 divided by 60 is what? 2/3. So 6 and 2/3 degrees. That's 20 thirds. Okay. All right. Is equal to now 5,120 divided by sine of 155 degrees, 50 minutes. So that's going to be 155 and 5/6 of a degree. So that's no. Plus 5, 935 sixth. So 935 sixth degrees. So, okay. Let's see. So 5,120 times sine of this many degrees divided by sine of this many degrees. About 1,452 feet.